Hi, my name's Steve from Conductive Labs. In this video, we're going to discuss what is terrain synthesis. Well, when I first conceived of this, I was thinking of wavetables. I was pondering how they worked and the idea of moving this this playhead. And you can look up here on the video. You see the green line there. I think of that as a playhead, and you can think of that moving across from one side to the other of a wavetable. And if I move that somewhere else, we get a different sound. And you can also move it as you're playing, and that gets you that classic wavetable sound. But I was thinking about the math and how it all worked, and I was thinking about, okay, so there's so many samples across the table, and there's so many waveforms in that table. And then I started thinking about the math, and I started actually daydreaming a little bit because it started getting a little difficult mathematically. And one of the little dreams that I had, a little daydream I had in my mind is what would happen if you actually rotated the waveform? What if you actually did this and played across the different waveforms? And I thought, wow, that's a really cool idea. And I realized though that when you do this, if you look at the end of the waveform, they're not always connecting. What I mean by that is the first sample isn't always the same as the last sample. If you look at this really closely, let's see, right here you can see this line shooting upward, and that's got to wrap around attached to this side. And that's going to pretty much make it sound like a sawtooth wave every time. It's because it's called a discontinuity in the waveform. So in order to get around discontinuities in a wavetable, what they do is they make sure that the first sample is equal to the last sample, so that when it wraps around, you can see here that this wave and that attaches to that wave, and it's got continuity. Well, in order to get continuity in a random position on a table, you need to have a closed curve. Basically, if the first sample swings all the way around and is right next to the last sample, then of course they're going to be continuous. So I thought, well, instead of using a line, what happens if we use a different kind of a path? And in this case, I thought of a circle. So if we look at the circle here on this terrain and I play it, I thought, well, would that make a decent sound or not? And I was thinking, well, wow, if you did that, you could move the circle around in X and in Y, and you could make it bigger and smaller. And then what happens if you get close to the edge and you make it so big that it hits the edge? Well, I just decided that reflecting it back would be the best. And you can see it bending back as I move it closer like that. So it bends back on itself, it folds back. And I thought, well, you could also use a whole bunch of different types of waves. You could use paths. You could have squares and stars and biohazard symbols. You can even have these Lisa Joule curves where if you go to the, you could change the phase of it, sweep the phase. And then I started getting creative and thinking about all these ideas about what kind of shapes you could have, and then rotating them and all kinds of stuff like that. Then of course it occurred to me that at some point you would be able to modulate these things, be able to modulate the rotation of that. So if we grab the rotation knob and switch on an LFO here, actually what's a neat thing is if you make the LFO max and make it a sawtooth, it'll just keep spinning forever and ever. Because once it gets to the bottom, it just shoots up to the top, and that's 360 degrees. We can also look at this a different way. If we look at it from the top point of view, you can see what it looks like. Yep. There we go. I have this phase button overloaded. There we go. So there's your square. when you're not using a Lisa Joule curve and you mess with the phase, it actually distorts the the path. So let's just leave that path at 0, and it's a perfect square. So that was the idea of coming up with the terrains. And then I also had the idea, well, instead of using wave tables as the terrain, you could create your own terrains. And that's where this idea of using these different kinds of terrains. Oops, let me initialize terrain. There we go. And all these terrains based on different kinds of positions will, oops, that's rotation. What am I looking at? Yeah, there we go. Get you all kinds of fun waveforms to play with. Instead of using an LFO, you could also, let's go ahead and turn that LFO off. Oop, there you go. You could also create a change based on envelope. So if we did a little, oops, that's really quick. Let's give us a longer. It's a little much. Just give it a little bit of a twist. I realized that, wow, this is really cool because you're changing the timbre. So this is a whole different way of changing the timbre. I mean, typical in like subtractive synths, we would use a filter and resonance to change the timbre, but this gives us a whole new way to do that. Then I did some research to see if anybody else had the same idea, and well, of course they did. The earliest research I found was 1970. Well, it was a 1979 article in a book called the Byte Computer Music book. And what that was, Byte was an old computer magazine, and they had taken all of the computer music articles that they had up until 1979 and collected them all and put them in one volume and called it the Byte Computer Music book. It was the very last article in that book, and it was from a guy named Richard Gold, and he talked about building a terrain synthesis. I couldn't believe that it was so far early, and he actually made a program that created the waveform. It couldn't play it or anything like that. He used nearly all the memory in the computer just to compute the waveform. But one of the cool things is in the back of the magazine they had an actual listing of the source code, and in it was a data set. And I actually made a table. I'm sorry, a terrain. Let's go over there of that. And let me see if I can find that. I'll show it to you. What was really funny is that because the computer, where is that thing? Oh, there it is. What was really funny is that it was only 16 by 16, and you could see I kept it as it was in the book. So that was literally 16 samples by 16 samples. Most wave tables today are 2048 samples. It's like 1 million times bigger. Well, not quite 1 million, but you get the idea. And this is quite buzzy, of course. So I decided to smooth it out, and so here's a smoother version of his table. But what I think is so cool is that in this synth we've got the original terrain thought of by Richard Gold from 1970. I think it was 78 that he'd written the article. The book came out in 79. Anyway, I just thought that was super cool. Now, there's been plenty of references to wave terrain synthesis. You can go to Google and type it in, and you'll probably find several research papers and from various electronic music schools. I think the computer, I can't remember the name of the book, but there is some references, but there hasn't been a synthesizer, a full-fledged synthesizer with dedicated oscillators to terrain synthesis yet. And so, well, we're happy to be the first one to bring it out, and it has met and exceeded all my expectations of a cool new way to do synthesis. So thanks very much for watching. I hope this explains a little bit on how it all works, and we'll talk to you next time. Thanks so much.